Hey guys, I'm sorry I'm not here today, but I wanted to go through an example of each of these problems with you. This should be review from Math 2, and so hopefully it doesn't feel too overwhelming, but I just wanted to make sure that I went over a couple of these with you, so if you feel stuck, you can get unstuck. So first one. When we take the square roots of things, remember you have to put plus or minus, and the reason for that is because say I wanted to take a number and square it to get 36. Yes, 6 works because 6 times 6 is 36, but you know what else works? Negative 6, because negative 6 times negative 6 is also 36. So mathematicians, instead of writing positive 6 and negative 6, they got lazy and they say, I'm just going to write plus or minus 6. So plus or minus 6 squared equals 36, positive or negative. So when you take the square root, pretty please make sure you put a plus or minus in front of your answer to indicate that there's more than one possible simplification. Now, number 5 is a little bit trickier because 300 is not a perfect square. So what your job is you need to make what's called a prime factor tree. What that means is we're going to split this up into all of its prime factors. So you are going to take two numbers that multiply to give you 300. There's lots of different choices. I like to start with 2 if it's an even number, just because that gets those little baby numbers out of the way. So 2 and 150 multiply to 300. So 2 is prime, so I'm going to stop. But 150 is not. So you can break this into, let's do 15 and 10. Neither of those are prime. 15 breaks into 3 and 5. Those are both prime. 10 breaks into 2 and 5. Those are both prime. So what's going to happen now is we are going to choose our pairs of numbers, because if you have 2 times 2, that's 4. That's a perfect square. So 2 and 2 is a pair, and then 5 and 5 is a pair. And then 3 is a loner. He's sad, so he's on his own. So we've got a pair of 2s. We've got a pair of 5. And then we've got a lonely 3, some sad 3. So what's going to happen is the 2 and the 5 are going to come out. So 2 times 5 is 10, so we're going to have 10 on the outside. And then that lonely 3 is going to stay on the inside. So this one's a little bit tricky because there's a number out in front, but what we're going to do is we're going to split up that 8 into its prime factors. So 2 and 4, 2 is prime, so we're going to stop. 4 splits into 2 and 2. And then everywhere we have a pair, we can take them out. So we've got a pair of 2s, they're going to come out. And since there's already a 5 there, we're going to multiply with what's already there. So 2 is going to come out. 2 times that 5 is 10. And then what's still left under the radical is little baby 2. The last one is a bit trickier because we are never ever allowed to have radicals in our denominator. So we use a process called rationalizing the denominator. Square roots are not rational numbers, so we want to make them rational. So the way that we do this is when we have a square root in the denominator, we multiply the top and the bottom by the same square root. We're going to multiply by a fancy 1, just like we've done in the past. So this fancy 1 is going to be the square root of 3 over the square root of 3. We're going to multiply by the square root of 3 because that's what's in the denominator. The reason for this is because we're going to go across the top. We're going to get the square root of 15. And then across the bottom, we're going to get the square root of 9. So why was that helpful to us? 9's a perfect square. So we can write this as the square root of 15 over positive 3. And now the denominator is rational because it's no longer a square root. It's an integer, 3. So this is going to be our answer. All right, the next thing y'all are taking a look at is the Pythagorean theorem. And the Pythagorean theorem is a squared plus b squared equals c squared. So all of these examples below are in this format. So I'm just going to go over 1 or 2 of these with you. So this first one says 3 squared plus 4 squared equals x squared. So 3 squared is 9 plus 16 equals x squared. So 9 and 16 is 25, is x squared, so x equals 5. Now you might say, we just talked on the other page, and the square root of any number is plus or minus, and you're right. But if you notice below, we're going to be looking at triangles. We're going to ignore the negative length. And the reason for that is because there's no such thing as negative measurements of triangles. So even though technically, yes, we would do plus or minus here, we're not going to do minus because we're not going to be working with negatives. So this one, number 4, is a little bit different. We've got x squared plus 9 equals 16. Subtract 9 from both sides. X squared equals, so 16 minus 9 is 7, so x equals the square root of 7, which can't be simplified. So you have those pages to do, and then also the top of page 11, you need to find those reference angles, and you should be able to do that no problem because we already did reference angles in class. So good luck with everything. Please work hard and practice hard, and I will see you tomorrow.